Hi, my name is Zin Yu, and my topic is Case Study in the Arts. My goal for this project was to create a convolutional neural network to classify art images by their medium. The classifications I'm targeting are watercolors, oil paint, pen ink, and graphite. I used the Behance artistic media dataset for building my model. This dataset consists of about 2.5 million artworks created by professional artists and labeled by crowdsourcing efforts. For my project, I only used a subset of about 4,000 images. To access the dataset, you must manually annotate 100 images. Afterwards, you'll be given a link to download a SQLite 3 database. The database has a list of 389,000 image links sorted by various categories. Some samples of the images are shown here. These are the watercolor ones, the oil paint, pen ink, and graphite ones. In terms of the hardware, I just used a basic MacBook Air to do just basic programming tasks and data preprocessing. For training the data model, I used AWS EC2 instance, the P2 extra large instance, and generally it was fairly quick at training the models within a couple of minutes. In terms of software, I used mainly Python 3 and Jupyter Notebooks. I did have to use a SQLite 3 library for Python because the dataset came in a SQLite 3 database. For APIs, I used Keras and TensorFlow for the deep learning parts, and image manipulation, I used OpenCV2, Image Hash, and Pillow. For file manipulation and other web utilities, I used OS, SHUT, util, and URLlib. Other data utilities include pandas, numpy, and matplotlib. So to gather the data, I had to query the SQLite 3 database through Python. And one of the first things I did was look at the SQLite 3 schema for this particular database. There are a few examples online for this specific dataset. And I basically looked at the examples and used that to query the images by media. And as you can see at the top, the get image URLs function, that's where I am executing the query to the SQLite 3 database and getting a list of links back for each image. And then in the middle of the slide, the download image from URLs function, that's where I actually iterate through a list of URLs and download them to a specific folder. So at the very bottom, you can see the actual executions of those functions. So I'm creating a variable called watercolor thumbnail URLs, and that's where I query SQLite 3 to get a list of watercolor images. I'm getting 1,100 images because I'm expecting some of the links not to work, or the images are no longer there. So I'm getting a little bit extra to get about 1,000 images. So below that, I'm actually executing the download image from URLs function, and I'm passing it in the watercolor thumbnail URLs list. And the other two parameters basically mean I am saving the images to a folder named watercolor, and each of the images are going to have a base name of watercolor and a number after it. So the first step of pre-processing the data, I basically resized the image to 140 by 140 pixels. I did this mainly to just reduce the size of the data set because later on I'm going to move the whole data set to AWS so we can train the data model on it. And then the second step of data preprocessing, I'm effectively removing any duplicates I find in the folders. So I basically loop through the 4 folders you see below in the in the function call, clean penning, clean watercolor, clean oil paint, and clean graphite. And I'm going through each of them and then getting a hash of the image bits. And if I see that any of the hashes match, I delete one of the images. And then the final step of data preprocessing, I am just putting all the images in a training, test, and validation folder. So in each class, for example, in the watercolor class, I am putting about 700 images in the training folder, 100 in the test, and 100 in the validation. So for the convolutional neural network model, I basically had three different candidates. The first one only had two layers of stacked convolutional 2D and max pooling 2D layers. So you can see up to the blue portion is where the first model ended. And then the second model, I added another layer, which you can see indicated in the red text. And then the final third model is highlighted in the orange text. And everything in black is what was included in all of the models. So here are the training results of the three data models. The first you can see is the two stacked layers of convolutional 2D and max pooling layers that came out to give an accuracy of about 25%. And then when we increased it by one more layer to three stacked layers, we actually got quite a good test accuracy at 91%. Then for the four layer one, we got basically the same test accuracy as the three layer model. To demonstrate the model in action, I've downloaded a set of 4 images, each belonging to one of the classes. Now I'll use the 3-layer CNN model mentioned earlier to predict the classifications of each. The model correctly predicts the first as an oil painting, second as a watercolor, third as a pen ink drawing, and the last one as a graphite drawing. So in summary, yes, it's quite feasible to develop a CNN to classify art media, and we can get pretty good accuracy at about 91% using a set of about 4,000 images, 1,000 from each art medium. So the biggest lesson I took away from this project was that the data set is crucial. Having 400 images per class is not enough. I originally intended to take the data set from reddit.com just by scraping images from art subreddits, but the accuracy while training was very low. Test accuracy was even lower. I think I got about 50%. Another lesson I learned through this is modularizing your functions and code as you go along is great. This reduced a lot of rework I had to do when I had to change data sets. At a minimum, separate functions depending on runtime. So if you're querying a list of URLs from a database, you kind of want to separate that out from downloading images from those same URLs. And it's just best practice to split up functions at a high level to kind of download and gathering data, pre-processing the data, and then finally training your models, saving the models, and charting the diagnostic plots. And that's it. Thank you for listening.